Hello everyone, I want to welcome you to my YouTube channel for the Atari home bit computer system. Now if you've also come to this channel learning about programming, from basic programming to assembly language, you are in the right place. I do have a background in not only programming with Atari computers but also programming with the Commodore 64, and I've used the Apple while I was in school, and also I've used Tandy, the Coco computer. My neighbor used to have the computer, and I learned some of the concepts with that. So you're basically good at really good coverage here in this series. And this series is kind of continuing on where we left off. I recommend starting with them in order from the beginner one. Move through them one by one. Start with the keyboard and sound. And then the last one I just posted was recently, let's see, it was a lottery program, so it was about variables. You would learn about variables in that one. And what else was in that one? Input, variables, keyboard. I can't even recall right now what it was in. But look for the one that says the variables in that, and you'll be able to learn some more information. If I looked it up here real quick, I could probably find it, just to make sure I'm keeping you on site. But that's what this channel is about. It's going to teach you a lot about how to get the most out of your Atari computer. I do have a lot of experience. I've played with Atari computers since, believe it or not, 1986. That's when I bought my first computer, and I know it's the year 2012 already, and we're coming close to 2013, but I do have a lot of experience, and I can kind of take you down that road. Now I looked it up here. I don't know why I couldn't think of it. It was random numbers. So random numbers and variables. You want to also check out basic programming for the Atari, Commodore, and Apple Tandy on that one. And you also want to check out tutorial keyboard and sound. You could probably check out some of the simple ones like simple game design and that. That'll kind of give you an overview of where we're going here, because this lesson is going to be a little bit more advanced. It's going to kind of feed on one from the next. So as you start learning new material and you go through the videos, you'll notice that I'll take you up in steps, because I want to eventually help you graduate and be able to write any kind of game program you want. Because I'm at the point right now, if I sit down, I can put my mind to it. I can pretty much come up with any kind of game design that you might see, like in the Atari 2600 series. I'm getting pretty close to mastering fine scrolling right now. I've already got a video out there on the internet. So assembly language, I don't really get stuck on that. So that kind of stuff is where you could eventually go. So if you keep learning more about programming, as you learn about the concepts, you understand how incrementing and decrementing works, how for loops work, how data statements work, and basically how memory operates within your computer, you're that much closer to becoming a really effective game designer. I mean, once you put a project plan and a plan together in general, you can come up with whatever your imagination decides. So at this point, this video is going to I'm going to start it off teaching you about the fornects. We're going to learn some simple fornects. Maybe I'll show you some delays and stuff like that, and I'll see where it kind of extends from this point. I like to try to also, if I can keep these videos focused on trying to implement some kind of a game design into each video series, I think that would probably keep people intrigued about programming, instead of just looking at it as some kind of boring concept that's going to get them through school or anything. I mean, think about it. I look at programming as a very passionate experience, and I love to sit down here and just turn on my computer every day. Matter of fact, I'm the kind of neat, nerdy, geek guy, whatever you want to call me, that can't wait to get home just to get a stab at this computer. I do have a degree in Bachelor Computer Science, so I'm pretty skilled in a lot of areas other than just the Atari computer. I've actually studied in the field and worked as a programmer, designing ASP.NET, C# applications, stuff like that. And also on my channel, if you're interested, I do have C++ tutorials for those who are interested in learning about C++. So let's keep this one obviously focused on the Atari for now, so I'm going to kind of center the camera around here so you can see the screen here. I'm using an LCD monitor, so you'll be able to get a good projection here. So usually like to just start out from scratch here. So what we're going to do is I'm going to kind of design as we go through it and implement as things come along here. Let's see here. So what we're going to do is I'm going to set up a couple of remark statements. These are just comments to explain the program. For next loops and more, say something like that. So whatever else I decide to come up with in this series will be appended to this as we go along. Okay, so what I'm going to do is I'm going to operate this program, this example, I guess I should abbreviate, sorry guys, out of Graphics 3. And Graphics 3, let me kind of run it to show you. Graphics 3, and I've explained this in other videos, it has a fine resolution here from 0 to 39 across, and it goes from 0 to 19 down to the text window here. And as you go below the text window, you're going at 20, 21, 22, 23. Now you can't write into the text window, but you can issue a Graphics 3 plus 16, and that will alleviate or remove the text window from the screen. And that's if you want to control the entire screen for drawing and stuff like that. So what this video is going to do is going to teach you also a little bit about graphics mode. I know you can't see the text window as I look over here, but there's a text window down here with the ready prompt in the left hand corner. I'm going to show you how you can use this it's basically a drawing pad, so you can kind of draw lines on the screen, and you'll see there will be orange lines, green lines, and there's a blue line. Although the camera may not pick up all that depending on how the focus is set here. So I'll kind of get you started. I'm going to use for loops to show you how you can kind of draw lines at certain speeds, and we'll maybe speed them up, slow them down, maybe bring one going backward just to show you how the different for loops operate. We'll see where that goes. I'd like to evolve it into a game, but at this point it's still in my mind to decide what to do. I'm thinking of maybe, it might be too advanced in this section. I was thinking maybe a paddle game, but I think that might be a little bit too far-fetched at this point. I want to try to keep them up for loops in this example, unless I decide to go into anything else. Like I may even, I may add like the read data statement or something. I've been wanting to show people that, but I just don't want to try to mix these up too soon for people to get confused. So let's just kind of get that started here. Flip back to Graphics 0. This is Graphics 3. When you hit reset, this is Graphics 0. And Graphics 0, for those who want to know, has a resolution pretty close to the same from 0 to 39, 0 to 23 going down. So, oh, I just now thought of what I can show you here. I was going to think about showing you the position statement. That may not work in Graphics 3. We may have to go to Graphics 1 for that, because Graphics 3 uses plot and draw to. You don't usually position dots. You usually just plot them or draw them. So let's kind of get that set up here. So I'll go back to the program. And the first thing we'll do is we'll initialize a color base here. Now for those who don't know about variables, I'll explain that right here. Just watch the video on variables. I'll just say setup, necessary, and then we'll set up another line here, variables. And then we're going to set up one called color, or COL for color. I'll set that to 1. And then we'll set up positions, X and Y. Like I said, this is going to require some knowledge of variables, so you might want to go back and study those. We're going to set it up to X and Y. And then let me set this next line up to explain this. And I'll run this and show you. Well, before I run it, let me explain it. Because I like to kind of explain everything. I don't like to just try to jump into stuff hoping people assume they know. A variable basically initializes a value and can hold a number. And keep in mind, variables, regular variables like integer variables, can only hold numbers. They can hold negative and positive numbers. You can also have them hold decimal numbers. Okay, so this one, an example, is only going to hold single numbers, or which are known as integers, basically. So an integer here, or just a value, as they called it in the old days, is going to be set to 1. So we're going to set COL equals 1. And you set a colon to separate the lines, so you can put more than one statement on line when you use the colons like that. In Atari Basic, that is, and Commodore does that too, and I believe Tandy and Apple all do that too. Okay, so the next thing you're going to do, we're setting up is a variable here just called X, and we're setting it equal to 0, and then we're doing the same thing to Y. We're setting that equal to 0. The next line says plot X comma Y. Now if you recall earlier what I said about the screen dimensions being from 0 to 39 and 0 down to 19, not counting the text window in Graphics 3, what this is going to do on this line is it's going to look for the coordinates that you set in the variables of X and Y. And if you look up here, basically it's just taking these and sticking them in here. So if you take out the X and Y, you get plot 0 comma 0, because that's what these correspond to. Now when I run this, it'll appear with, this is, by the way, I forgot to mention, color dot in the upper right hand screen. I'm sorry, the upper left hand screen. I also need to turn on the color, so I need to put that in here, excuse excuse me, you can just set it beside it like this, insert over, and just type color COL, which represents the 1. Remember, color, anytime you use a variable COL or whatever you want to call it, and you're just going to take that value that's being initialized into it and just stick it in here. So it basically says color 1 plot 0, 0. That's right. And there we have our friendly little dot up in the screen, our little square. So let's go ahead and start with some 4 next loops to show you how these work. Now, the way this works is a 4 next loop. What we're going to do to not confuse people is I'm just going to use my own variable to set up the dimensions for this. I'm going to set one for A equals 0 to 39. So basically the 0 to 39 is just representing the dimension of the screen. So basically it's going to start from 0 to 39 over here. Now keep in mind that's one variable. This is going to get a little bit more confusing. We're going to nest this variable inside. I hate to do this really early in the program. Let's see if I could get away with this. Actually, you know, I can get away with it for now. I don't want to confuse people, so I'm just going to say plot A, comma, 0. And that's going to keep track of the line where the dot is appearing at. So right now, what this is doing is it's going through a loop here. Keep in mind, a loop is a way of just counting through a list of items or numbers. This is going to count from 0 to 39 with no increments in between. So basically it says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 39. So what this is doing right now is it's taking all the dimensions you have inside of here, or all the spaces of 0 to 39. Each time it's going to keep going in here when I set up the next here statement, and it's going to move a line all the way across the screen here. From 0, because it's that 0 line, these are also, I probably forgot to mention this, excuse me. This is the horizontal direction, which is left and right, and this is the vertical, which is up and down. So it's setting 0 at the Y, which means it's at the vertical. So think of your screen as from, like I said, 0 to 23. So 0 would be at the top. So this one's going to start at the top, and X, or A, I just called it A in this case, not to confuse this one up here, is going to basically take and start it over here, 0, and it's going to move it all the way over here to 39. So if this works, it'll draw a line across the screen in a for loop. You can also do this with a draw to statement, but I just wanted to show you how you can also do it with the for loop. And then later we'll maybe make the line draw a little bit slower, and I'll show you how to slow it down and set up delays and show you the power of for next loops. Okay, so we'll just set up next A. Now it should draw a line across the screen when we're done here. Okay, so there's our line. It just basically took it from 0 to 39, and it stayed at line 0. Now the next thing we could do is we can draw another, we'll set up another for loop, and we'll set it underneath the line here. What I'm going to do this time, well, I'll change the color to probably make this a little bit more obvious here, is I'm going to teach you something new. I think it's probably time. Well, maybe I'll do it backward. I wanted to do it backward, but you might not see it because it goes pretty fast. But I want to do one starting from here and make it go backward, and then maybe later we'll slow it down to kind of explain. I'll explain how that works. So let's see. Okay, so we're going to use a brand new for loop. So you can just say for A, if you want to use A again, you can use that. I'm going to use B, just not to confuse people here, since we're starting 39 to 0, step -1. I'll explain this. And you just say plot B, because we're not using A this time, comma 2. We're going to jump down 2 lines, and we're just going to set up our next B. Now before I run this, I wanted to explain this to you once again. Think of the A and the B as just variable, or a way of representing an area that you're going to be moving through. This is from 0 to 39. This is also going to be moving, except it's going to use the variable B. Like I said, you can use A or B, it doesn't matter, as long as you still follow the next A, for loop A with the A, and the for B with the next B. If you ever miss one of these, the computer will complain and give you an error message. Now I want to explain what this is doing. So if you look at the line here again, notice that there's a 2 in this space where the vertical column is. That means it's going to, instead of going at 0, it's going to drop down 2 lines underneath it to kind of give us room. Because I didn't want to draw one immediately underneath it. You might not see it very well. So I moved it down 2 lines so you can see it. It's going to start over here, by the way. And the reason why it's starting over here is, in the solution is to look at the B here. If you look at the B, it starts at 39, which means it's going to start at 39 position. And it says here, notice it says 39, 2, 0, step minus 1. So what this is basically doing is it's a way of drawing the line backward, where it's going to increment backward from 39 to 0. So it's just like the other one going from 0, 1, 2, 3, 4, 5, 6. This one's going to initialize and start the point at 39. So it's going to say 39, 38, 37, 36, 35, 34, 33, 32, and so on until it reaches 0. And this step right here is necessary to make it move backward. If they didn't have this in, the computer wouldn't know how to increment it backward, and I guess this is how Atari Basic determines, and also Commodore and other computers I believe that use it, determines how which way the line's going to move. It's just a way of recognizing it. Okay, so you're going to see the line move backward. It'll be very fast, but you'll see it move that way. Like I said, later we'll slow it down. And then later we'll change the step, and I'll show you how you can move it in increments and stuff like that, or basically make it skip spaces. Okay, so let's run it. You're going to see them both appear very fast, so pay very careful attention. You see that one move across? And I forgot to change the color of that one. I can change it. Just to show you how to change the color. You just go in here, beside it. And we don't need to use color 2 because color is already equal to 1. I'm just going to set color 2. Now I'll draw the lines in a different color. Okay, I don't know if you can see it. It's kind of like a green color. And this one's an orange. So did you see it move across? I can run it from here and show you. Watch it real quickly. You see it move that way. See, the reason why it moved that way is because you started at 39, and this one moved this way. This one started at 0 and moved that way. Looks like they're both green now. Huh, that's weird. Let's see. You know what? Oh, you know why? Because I didn't change the color of this one. I deleted my color statement. It's not noticed that. Hold on. I forgot to use my arrow keys here for a minute. Okay, so let's go up here. I must have deleted it if someone wasn't paying attention, so I'm going to stick it back in here. Oh, I deleted that whole line. I just noticed that. Okay. Let me go ahead and put that line. It must have been line 70. Let me just add it back in here. Things happen when you're programming. You just have to keep an eye on it. Okay, so now what I wanted to do, I wanted to show you how to make it skip steps. And this time I'm going to keep it very simplistic. I'm just going to use another variable. Remember, you can use any variable you want. We're going to start this one at 0, and we're also going to move to 39. But notice the step is going to change to 3. I'll explain that. We're going to set up a new color, which will be blue. Keep it at C. Move it down to 4. And just use your next C. Okay. So now, once you're familiar with this one up here, A equals 0 to 39, you're not too far away from this one. Notice that there is a step like this one in front of it. But notice this one has a minus, and this one does not have a minus. This one is basically moving it backward. This one is moving it forward. So if you can almost guess here, if you look at it, it's going to count in steps of 3 to give you the answer, basically. So if you start at 0, and then you go to the next step, 3, it's counting at 3. So think of it like multiplying by 3. 0, 3, what's it, 0, 3, 9, I'm not very good at this, 12. You're just going to see it jumping in steps of 3. If I even said that right, you see 0, 3, oh sorry, 0, 3, 6, because 3 plus 3 is 6. And then 9, so you're counting by 3, so I'm right. 9 would be 3 times 3, 12, 3 times 4, 3 times 5, 15. So you're going to see it incrementing in steps of 3. And also it's going to start over here in the corner because we still have it set to 0. But it's going to go down 4 lines instead of going down 2. So each of these are skipping down 2 lines. This one's at 0, this one's at 2, and this one's at 4 in the vertical. So watch what it does this time. And you should see, you won't see a line on the 3rd line, but you'll see something. Can you guess? If you had to guess, what do you think it's going to do? Watch it and we'll see. Not interesting. So what you're looking at here is the same line being drawn with a for loop but this time it's jumping in steps of 3. So it's basically plotting each time it reaches the new third line, and it's just how you basically make lines jump across the screen. So you basically learned how the for loop works. It kind of goes doot, 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 doot. You can change this step to any increment you want. If you set it to step 30, it would only show a dot here and here because that's how far the dimensions are. If you set it to 12, you would see it jumping in between and stuff like that. That's basically how you get things to skip in between. Okay, so I've showed that. We can do the same thing going backward. Just to show you it works, I'm going to set up a new variable. 39 to 0 step. Let's make this one negative 5. Let's do it at like 10 or something. We'll make it jump a little faster. And then we just set color. We've already got that. We'll just go back to 1. There's only 3 colors other than counting the background color in graphic 0. So there's black, and there's orange, there's green, and there's blue. Okay, so plot D, comma 6. Just jump down the next line, to the next D. Once again, to explain, this time we're saying for D equals 39 to 0, step minus 10. Now if you look back here on the earlier line where we used our minus, it was back here on line 100, and it says 39 to 0, step minus 1. So this was starting at 0 and moving backward 1 time each space. So it's basically not skipping in it. This negative 1 means just move it back by 1 each time. That's why you saw a line go straight across. This time, however, we're also going to start over at 39, but notice over here in the step it says minus 10. So like the one we saw earlier, that's moving this way and just basically plotting lines here, you're going to see this one jump big lines in between. So there may be about maybe 5 or 6 of them on the screen. So 10 divided by 39, maybe 3 or 4 or something like that. So watch it, and it's also going to go down to the 6th line because once again we're just jumping down 2 lines just for clarity so people can see it. I'll show you. That was close. I thought it would be 5, but it ended up being 4. So that you see over here, it started with 1.39, then it jumped way over here, and then way over here, and over here. So it's just jumping in 10 steps. So there's 10 spaces in between each of these, or 10 positions, if you will. Pixels. I think that's what the computer refers to that. Now I wanted to show you something else here. So what I'm going to do now is I'm going to, I hate to clear the screen. I'll teach you the delay loop, just take out and give it to you. For delay equals 1 to 500, next delay. Let's see, next delay, print, watch this, to 10. Let's see, delay equals 1 to 502, next delay. What I want to do is I want to make it print this message and delay a line as it's going through it. I didn't want to confuse people. I think I'm going to set this one down here for delay equals 1 to 500, next delay. And then this one, I'm going to set this to A or something like that. And we're going to make the message print 100 times. This is what I'm going to do is I'm going to teach you about nested loops now, so don't get mad at me. I know it's going to be a little bit difficult to follow, but if this works correctly, what you're looking at now is something called a nested loop. What a nested loop means, it's a loop inside of a loop. So here's how it works. It works very similar to what we saw earlier. So you're seeing for A equals 1 to 100. So like the one we saw earlier that started at 0 to 39, this one is starting its point at 1 and just counting in steps of 100. So you're looking in exactly the same order, starting at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think you get it. It goes all the way up to 100. There's no steps in between, so it's not going to skip any steps because we want to get the full incrementation of 100 series. Because what I want to do is I want to print this message 100 times on the screen. And if you look here, the next line, it says print, watch this. Just a little message I set up. Now the next line you'll have to pay attention to because it's going to feed off of this one, and I'll show you why. This one, yeah, I'm kind of giving a hint at it. It says for delay equals 1 to 50. Now I need to change that 50 actually. We'll make it 250 might be a good. 50 would probably go too fast. For delay equals 1 to 250. Next delay, next A. So what this is doing is it's setting up a small stopping point in between, so your message doesn't just go through the screen very quickly and go through the whole steps or set of instructions very quickly. It's going to slow it down so you can kind of watch it. That's why it's saying watch this hint. And what it's going to do is it's going to count from 1 to 250 with no steps in between. Next delay. So this is going to execute a full delay without anything in between. You noticed earlier this stuff was all embedded inside of here. So this is just basically going to slow the computer down and make it count from 1 to 250. Once it reaches 250, it's going to hit this next A, which you remember earlier here, if you can see, it was basically saying for A equals 1 to 100. So once you've gone through this loop and it's completed delay, and the delay is now equal to 250, then A is going to increment its next location. That's what next A means. And suddenly it's going to be a 2. So now it's going into 2, and it's going to jump back up here again, so it can go to the next series of execution for A. And then it's going to go through the next A. A is now equal to 2. It's going to print a new message. Watch this. It's the same message, but it's going to print down another line. And then you're going to get your delay to slow down the message a little bit again. And then next A again. So now A is going to be 3. Print the message. Go from 1 to 250. Slow down the message. Next A. Now A is 4. So you probably get the point. It's just going back here and changing it each time until it hits 100. I might change this 100 because it might take forever for us to watch it. Let's do something like, I don't know, maybe 25. We'll see how fast that goes. Now watch what happens. You're still going to see all the same things happen. You're going to see all the lines being drawn on the screen because it's still following our code in sequence until it gets to this line. And then it's going to, basically, you're going to see this message appear down here in the text window. And that's what this does. It says print without a number 6 sign in front of it. You might have seen that number 6 in some of my other graphics videos. The number 6 means print it to the screen, and we only print in graphics modes that have text in them, like graphics 1, 2, 13, and 14, and so on. So this one's just going to print in the text window so we can see it. And also, probably for clarity, let's turn off the cursor just so it kind of looks good. I'll do that up here. I just like mine looking nice. Just poke 752, comma 1, that will turn off your cursor while it's running. So here it goes. Let's watch it. There it goes. Now it looks like you can see it good over here. You can't really tell. It's actually incrementing this over and over again. It looks like it's changing over here. I can't really see it very well, but it's changing, and it keeps printing new messages here. Now I could also put a number here in front of it to show you that it's working. And there it just finished. So it went through 25 incrementations. So let's go ahead and put a number in front of it. For those who know about concatenation, I'm just basically going to take this message and stick a number in front here. We're going to print A in front of it so you can see the message. And just stick a space in between here. And that semicolon will keep all this on the same line. So whenever you use a semicolon, it's going to take the next statement and jump it up and put it on the same line. Without the semicolon, it won't be able to do that. It would just go to the next print statement. But after this, there's no semicolon, so we just jump down to the next one. And what this is going to do, if you saw earlier where it says A equals 1 to 25, every time A is changing from 1, 2, 3, 4, it's going to keep changing this number, and between it, it's going to put a space in the middle. You just take 2 quotes and you stick 2 semicolons to get a space there. And right after this, over here, it's going to put this message right beside it. So think of these as being combined into 2 lines. Now I could have put these on the same line, but I didn't want to confuse people for a beginner series. So let's watch it and see what happens. And that's just so you can see that it's actually working. There it goes. Now I can look over here, it looks good. You can see the numbers counting as it's going up. I'll stay away from the screen, it doesn't like me when I touch the screen very much. So it's basically changing the number until it gets to 25. It's counting. And there we go. Reached A is now equal to 25, so it's completed its process. Okay. Alright. Let's get into some more stuff here. I hope you got a grasp on how the for loop works now. I wanted to kind of go into some animation after this. What I'm going to do is I'm going to set, I guess we could just do graphics 3 again. It's going to jump to a new graph. This GR.3, by the way, is a shortcut for graphics 3. You might have seen me do that. Or you can just type out graphics 3. I like doing shortcuts, so excuse me on that. I'll make the line blue. And we're going to make this dot travel across the screen at a slow pace. So, very similar to what we did earlier. A equals 39 to step. No, we don't need a step. 0 to 39. We'll move the line down a little bit to kind of give it some centering. So A, maybe down 15 lines might be good. And remember in here we need to embed the delay statement so it slows down the program. I hope that'll be enough. And then we're going to embed our next A inside of it. So let me relist the program so you can see what's going on. So, once we're done with the last message where it says next delay and it goes through all the watch this, once those are done and A is equal 25, I just basically made it start over with the new graphics 3 mode so we can kind of clear the screen. There's another way to clear the screen, but I didn't want to confuse people, so I figured it'd be easier just throwing in the graphics 3. Going to set color blue, that's color 3. And we're going to do very similar to what we saw earlier. For A equals 0 to 39, so it's going to count from 0 to 39 with no jumps in between. And this is what the A is doing. And then it's going to plot, once it's plotted A at the horizontal and vertical, excuse me, the horizontal, it's going to jump down 15 lines here. And since A starts at 0, it's going to start way over here, but it's going to be about in the center of the screen. And you know this one, I told this one earlier. This is a delay loop, so it's going to slow down the loop and count up from 1 to 250 and wait until it's done. It's going to keep going back here until it's reached the end. Once it's done here, it'll go back to our next A. And that's not the next A up here, by the way. Next A is only followed with the new for loop that you've set up. So even if you set up a new next A, it won't look at this one because this one already completed earlier. So you can do them inside that. So basically it'll say next A. And A is now equal to 1, so it goes back up here. 0 to 39. A is now at 1, so basically moved it over 1 space. Go through our delay, kind of slow it down. Go back to next A. Now it's at 2, so it just moves it over another space. Slows it down. So you should see a line creeping across the screen. It might go a little bit faster than that. We'll kind of watch and see what it does here. Okay, you gotta wait for the message to complete first. That's why I didn't want to make it too high. It'd be long and boring to wait for it. Eventually I might change that counter too. And get tired of waiting for it. Okay, almost there. Let's see what happens. There it goes. Oh great, it's working great. See how it's kind of creeping? It looks like the line's growing. The delay's slowing it down at 250 increments each time, so it's giving it time to grow the line. Kind of looks like a worm or something moving across the screen, doesn't it? But it's slowing it down. You can see how the 4 next loops can come in handy. You can slow down animation and do kind of cool stuff with them. And it'll hit the end and that'll be it. Okay. Now, what I'm going to try to do is, let's see if we can set up some animation in this one. We're just going to turn off the line. Hopefully this works correctly. Then we're going to turn the line back on again. I'm going to speed it up a little bit. It's a little bit too slow for me. This one 2. And maybe make this 20. Let's go back and make those corrections. It'll just give us a little bit more time to save time with this video because we're already at half hour over here. So I'm going to run it again and it should move a little bit faster. I think I'll move the line up a little bit. See if we can get some animation on this one. And now the messages, you notice they're going faster because we changed the delay loop in this area. It's now at 150, so see it moves a little bit faster and it's at 20. So let's see. It didn't work because it turned it off and it never turned it back on. I probably forgot to turn it back on. Let me see. And this is a trial series, guys, so there's going to be things. I see. I put the color 3 outside the loop. So it was never able to turn the line back on, so we just need to set it up here. And our race line 250. I'll show you now. Whoops. earlier, the color loop was up here right after the graphics 3, color 1. So every time the loop of A was incrementing and it goes down here, it would only go back to the for loop, so it would never go outside of that. That's why I stuck it inside of here. So now, when the color's turned off on this line, that's what this line is doing, is turning the color off and it's doing the same plot. You should see the line moving across like in an animated way. Let's try it again. It's still drawing the line. Let's see. It's not what I wanted it to do. Let me see. So we erase the line, we draw the line. You might even have to erase the line first. Animation's always a little tricky. Let's see. Oh, I see what I did. I have two different lines going on here. I have 12 and 15. So one's a 0 and one. You didn't see it, but there's two lines moving there. So I'm going to run it again. It should work this time. But earlier there was one at 12 and there was one at 15. But the one that was at 15 or whatever was invisible and you couldn't see it. There it goes. Now you can see the animation moving across the screen. Isn't that pretty cool? Looks pretty good over here. You discovered one of the advantages to knowing for loops and knowing how to increment. You can create animation. There's a little dot. I take this in reference to a program I wrote many years ago. I called it Zoomy Quick. Basically, I just had a little dot racing across the screen here, and it went around the whole border, and it would get faster and faster each time. It would make a funny sound while it was moving. If I can only recall that sound, I'd put it in here. Let me just throw a sound in and see what we can get out of this anyway. For those who don't know, there's 4 sound channels in the Atari computer. You just use and initialize them like this. We'll set up a new line. You just say sound 0. In this place, since we're moving at A, we would say A. So if I'm going to multiply it by 2, I believe that was how I got the funny sound. You just set up a register to move it at. You set up a voice for it. And then you set up a volume. This last one is the volume. Let's see, 15 divided by A. I don't want to make this confusing for people. Okay, times 2. And we'll just set it to 13 or something for now. And at the very end here, we'll turn off the sound so it doesn't continue the sound. Let's see what it does when it runs. There it goes. It's just counting like little tones. Okay, so what it was doing is it was incrementing in A steps times 2 to get those kind of pitches on the screen. And next time I'll print them down here so you can see what A is doing. So we'll set up a new line down here to show you. We'll stick it inside our nested loop. Hopefully this doesn't get too advanced for people, but I wanted to kind of give you an upstart on what's really going on here. This is going to say sound. We'll just say sound value. And then we'll stick A over here so you can see what A is doing. It'll be A times 2 basically. So that'll give us a sound. Let's put 2 sound voices in here just to make it sound a little more cooler. I like things kind of cooler. 266. We'll set up a second voice. We'll change the pitch by a little bit, maybe 5. The voice, we're going to add distortion, so it's going to make a different kind of sound now. Lower the volume by a little bit. Actually, I think I'll probably raise the volume. And then we'll make sure to turn off both sounds at the end here. So let's see what this one does. I'll go back and explain it in a minute when you hear it. There we go. Well, that's weird. Oh, like a jet taking off or something. You can see the numbers counting. Actually, it looks like I just looked down the screen, you can't see them. I have to change the text window. Let's see if I set 712,128. Oops, I did it wrong with 17. Come on. Let's do this again. Graphics 3. Excuse me, I just want to test the window here. 710, 128. You can kind of see that. It's kind of dark over here. I don't know why it doesn't show up good over here. Let's see. 126 maybe? That's too bright. I think this one usually does pretty good. I don't know what it is about the text window. It never likes the text window. The colors never come out very good. I know you're going to see 0. Just trying to play with the color here. Gosh. Turn the color black and you still can't see that. How do you like that? Let's see. 7, 10, 52. 709. I don't know why. It's not going to let you see the text window. I guess what we're going to have to do maybe is just limit this to graphics 0 for now. I'll turn off the cursor and just show you the animation in here. We can still use the plot in graphics 3. It'll do the same thing. You're just not going to have the color on this one. So it's going to switch to graphics 0 this time instead of graphics 3 once this is done. And then you should be able to see the sound and see the numbers. I just thought of something else I could teach you. Oh, look at it's doing. It's moving the sound right beside it. That's because it's on the same line. And we didn't position sound, so right now it's just basically kind of scooting it. It looks kind of sloppy, if you ask me, but the numbers are changing. You can see the numbers are changing here by the steps that they're changing by. That's really stupid, doesn't it? Okay, enough of that. Well, I just send this to turn off the text window then, so you can see it. I'm going to set it to black. We'll make sure the color is 1. Let's speed up the delay a little bit here. Just changing a few things, guys, just so that you can see what's going on here. Now set the color value here, the 8 times 2. I can also set up another one besides it so you can see both of them. 8 times 5. Just to kind of give you an idea what's going on if you want to do this in your own programs. Okay, so I got graphics 3. Turned off the color window, so I think everything looks good. You should be able to see it now. Try it. Sometimes the only way to do is to turn off the text window here. You poke 710, 0, now we'll turn off the text window. Black, make it black. There it goes. Now you can see the dot because the dot is in the same background color. Just realize that. Underneath it. Turn that back on. So we're just gonna have a little fun on this one. We need to set that to color 1. I believe that will do it. There it goes. Looks like you can see the numbers now. This is the first set of sound. This is the second set of sound. They look kind of hard to see if I don't touch them. You can see them a little bit. See how they're incrementing and they're multiplying and they're changing? This one's multiplying by 2 and this one's multiplying by 5. So every time A is 2, it's going to be 2 times 2, and this is going to be 2 times 5. So just increment in those steps. Just to kind of give you some idea of what's going on here. Let's see, I'm trying to think what else I could do with for loops here to not make it too complicated. I've already explained the backward and forward. You can do up and down side animation. It's no different. You just basically change the direction of your plot. I'll do that anyway here just to show you. We'll just repeat these lines and we'll change the delay going down. So give me a minute and renumber them here. Go back and change them. We'll go back up here. And we'll just set this one to Y so you can understand Y is at the vertical axis. So this all these A's have to change to Y because now your A is no longer A, it's Y. That means this is going to change all your plots. Remember, all your A's are going to follow. All your for the next loop variables, except for the embedded ones, are going to have to change. We're going to leave that one a delay. We're going to set this to Y, and this to Y, and this to Y since it's our plot, and then next Y. Okay, I just forgot to do something else. What we need to do is we need to correspond a starting point for our x. We don't want to make it do the same thing we did earlier. We want to make it go down from the top to the bottom. So we need to find the center section for our x, which is 39 divided by 2 is 19. I believe 18 will do it. Usually doesn't look very good at 18. I'm just going to say something like 16 comma y. And you have to repeat this down here, 16 comma y. In other words, you won't see where it's drawing the line off at. That should do it. Now let me explain that. Okay, so everything's following the same thing. We got our graphics mode and everything. All that's going to stay the same. And let me relist the program because you probably can't see I just added new lines. So we got this one still going on. You're going to see the first animation and you're going to see the second one. Now when we get down to the second one here, it's just using a variable called y from 0 to 39. Just remember your a that we set up earlier does exactly the same thing, and actually I need to change this to 39 because I noticed that. Y can't go down to 39, it can only go down to 19. So I'll make that one 19. Sorry guys. So, y is going to go from 0 at the top of the screen down to 19. And it's going to have our sound in it. We're changing every occurrence that was once a is now y. So we're just basically changing those places of y. The next thing, once it's got the sounds in there, it's going to plot. Look over here, it's still got color 1, which is that orange color. And it's going to move the line over 16. So remember, this is your horizontal coordinates, which means your left and your right. So it's going to count over here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it's going to appear in the center of the screen here, or close to it. And y, since y starts, if you look here at 0, it's going to set the vertical starting at 0. So it's basically, you got it right where we want it, so we can move the line straight down the middle of the screen. And everything should work fine. And this just does the same thing. When y is 1, it jumps back here to this loop. Y is 2, it jumps back here after incrementing, going through all this stuff. Y is 3, it jumps back here. So it's very similar to what we did earlier, except it's just drawing it down and animating it down the middle of the screen. Let's try it with the music. There's our first one. Here it comes. There it goes. And there you go. There's a move it from across and moves it down. And you can see the values are still the same. Actually, they're different than the last one because remember the last one went from 0 to 39. This one's only going from 0 to 19, so it's not going to be able to, the numbers multiplied are not as higher since we're not going as far. If I stopped this one at 19, then you would see that they're exactly the same. I could do that, but it'll stop the line here toward the middle of the screen, just to show you that these numbers will be equal so that you can get an understanding of that. Let's do that anyway. Okay, let's see, where was my first one? Right here. Let's change that to 19, that's all you have to do. That will do it. Until you get tired of that loop counting, huh? There it goes. Now I'll only go over to 19, and we'll stop. You won't see the numbers, I didn't delay them. They were at 38.95. Let's see if they're the same. 38.95. This time, when I get it to the middle of the screen, I'll stop it so that you can see the numbers are the same. I just looked over here; they're kind of hard to see. Sorry, this camera's going out of focus again. Okay, zoom in. Maybe it doesn't like these bright numbers or something. I don't know if I'm going to make them any dimmer. I don't know how much more dimmer I can make them. This will be 8. 709, comma 3. 709, comma 5. I'm just changing the luminance of these colors. Those are much better. Let's see, 710, comma 5. Never likes those colors. Well, let's go back to it anyway. Hopefully you can see it. I'm just going to slow it down. So once we complete the first animation, it moves over from 0 to 19. I'm going to pause it right after we turn off the sound here and put a delay here so that you can read these numbers real quickly. If you want to write them down, you can kind of compare them to make sure that once the line goes down from 0 to 19 to see that they're the same. That's because y times 2 and y times 5 is still going to be incrementing in within y. And up here, you got the same thing except it's using a. A is equal to 0 to 19. Notice these are the same. And it's just basically using a, where here it's using y. So you'll see that they're the same. Just so you can kind of grasp that, hopefully. I'm just going to copy this line in between here, so we'll set it at 315. I'll relist it for you. So right after the sound quits on the first one, you'll see the delay will slow it down. I'll make this loop a little bit higher so you can read the numbers, but you'll be able to capture them on the screen. We'll set it to like 250. I guess that'd be good. We did that before. I'm going to speed up the lines a little bit, and they're going a little bit too slow for this time. We're running out of time here. Let's try 70. And down here, we'll just do another 70. There we go. Just kind of just slowed it down a little bit. Let's rerun it. Let's watch it in action. Let's go a little bit faster. Now you have time to read the numbers before they disappear. 3895. Hopefully you saw that. 3895, so they're identical. That just tells you that the loops are doing the same thing, just setting up different plots. It's like I'm running out of time on this one, as much as I wanted to have fun on this one. I put in more on here, but I don't know if we're going to get to more. Let's see. We could probably change the colors. I could just show you that as the last one, so you can kind of see some cool stuff with that. For C, what's that? C equals 0 to 255. That's how many colors there are. Or jump in between colors. Get kind of a color jump effect. You would just say poke 712, comma C. And we're going to set up a delay loop inside of here. We'll make it 100. It might make it kind of too slow. We'll set up 80. And we'll do our next C. Movie list. See what I did? So what this is going to do after all of our animation and everything completes, and you see the numbers on the screen here, we're going to set up a new variable that says for C equals 0 to 255, step 6. Now what this is doing, just like the ones you saw earlier, instead of jumping in regular steps from 0, 1, 2, 3, 4, so on, it's going to jump 6 each time. So 0 times 1 is 0, 0 times 6, well, I'm sorry, 0 times 6 is 0, 0 times 1 is 6, so now C is going to be equal to 6, and 6 times 2 is 12, 6 times 3 is 18. So what this is going to do is it's going to set inside of this poke statement, which is called 712, which controls the background color. So you're going to see the color change screens after all the animation has completed. I couldn't figure out what else to do with it, and it's going to slow down the animation here so you can see the colors changing, just to kind of really stick that in your head of how delays work, and for loops and all that. Let's watch it. Just trying to find the easiest way I can break this down for people. There's our first one. Now our second. Now the colors. There they go. They look good over here. I can see them on the screen. It's going up to 0 to 255. It is jumping in 6 steps of increments. You won't see the numbers changing here because I didn't print them to the screen. As a final teaching to this, or instruction, I'm going to go ahead and print the colors to the screen here just so that you can see that they're changing and see what they're showing. We'll take this line and we'll change it. We'll just say background color. That looks good to me. And this is going to change, and we don't want to use this. Remember, we're just using C. So we say C. I'll relist it and show you. So this time it's going to still change our colors, but at the bottom text window here, you're going to see it showing it's going to print out the words background color, then it's going to use the semicolon and concatenate the letter C, which is basically going to show you what the values of C are, so you can change them in increments. You'll see this number going from 0, 6, 12, and counting upward. Now it might go a little bit fast, so let me slow it down a little bit here, so you can kind of see it. There we go. Let's try that. There it goes. Watch the numbers count. There they go. See them counting by 6? Until they get to 255, you'll just see them counting increments of 6. And the delay slowing everything down so you can see the color going a little bit slower there. It'll probably take a while to get there. Sorry guys. I wanted to show you how they work and how you can slow things down with them. And print out those values. Almost done. We're done. So it didn't go 255 plus 6, because that would be 258, and you can only have 255 values in a background color or in a poke location. So it only went to 252. If you did set it to 256, you would get an error message. I could still do that if you want, maybe on the last round here, just to show you that I give you an error message. Let's speed up animation here, is running out of time here. I'll set this to 100. And we'll set this to 256, and you should get an error message at the very end. There it goes. Go a little bit faster. Now when it hit 256, you'll get an error message here. And teach you something about error messages. And that'll be the last thing I'll show you. For this one. I think it's going to be error 3 maybe. Oh, it didn't even give me an error. Let's see. 258. I must have not reached it. Probably had to make it 257. I think it jumped out before it got to the 256. Make it 257. That should do it. Hopefully it really works this time. There it goes. Come on, should go to like the 258, 263 or something like that. Oh, no, it's not giving me an error message. C is now at 258. I'm trying to get it to throw an error message with this poke statement. It should be given an error message in here, but it's not. That probably because it needs to reach the next 6 statement in this. So if I go something like 255 plus 6, oops, that might tell me where I need to go to. 261. And we set 257 plus 6, 263. You can do something like this, and then you'll definitely get an error message with this one. Speed it up here a little bit more for time consistency. There's a new listing. Let's try it again. If it doesn't this time, I guess I'll just quit it. Trying to force an error message here, and the computer doesn't want to do it. I'm guessing it's going to be error 3 if it does. I'm going to be wrong. Error 3 is a value error. There it is. I hope you can see it. Error 3 at line 430. So if we print C, which was the variable we were using, remember it's error 3, it's 258. So we tried to put in too high of a value into the poke location, And here's why. If you look at this book here, this is the owner's manual. And you go to the back here where it says error messages at the very back. You have this, you can get a PDF online. Look at what 3 says. This just tells you the error messages. Here's how you can also look up your error messages in your computer when you get them. Come on. A value expected to be a positive integer is negative. A value is not within a specific range. As I already predicted, based on experience, it was trying to poke 250. It's trying to poke 712, 258, but it's impossible. So if you go down here and you try to say poke 712, 258, you'll get the same error message. Right there. That's how you know. Nope. I think that'll probably conclude it for this one. I wanted to do more with this, but I think you have a good idea about how for and next loops works with delays and stuff like that. We didn't have time to turn it into a game. Maybe I'll do that next time. I really enjoyed doing that on the last one. But as we continue to advance our skills and we continue to learn more and more from the series, we'll be able to get more into game design, because it's going to take a lot of concepts to really understand game design. Like, you may not notice it in this video, you were learning about incrementing variables. So if you remember from the edit video I have with the lottery example where it shows money equals money plus award, think of award as being an incremented value as in a step place here. So if you have award equal to 1, it's going to say money equals money plus 1. So basically what you're looking at here is when you see for A equals 0 to 39, it's just saying A equals A plus 1, and it's just incrementing that A each time as it goes through the loop. The same thing with the money, it just increments money and keeps accumulating your money, basically. So hopefully that would explain something, because what I wanted to do next time, I'm really looking forward to this next video, is we're going to create a drawing program. And we're going to be able to, since we already know about the keyboard, we're going to be able to use the keyboard commands with the arrow keys to draw and move a cursor around on the screen to be able to draw, like with a drawing pad and stuff like that. It'll be kind of cool. So stay tuned for the next stuff. If you're interested in subscribing, definitely go ahead and subscribe. Looks like this channel is taking off, and I'm pretty excited about that. I'm willing to teach everything I know and just take you up to speed as quickly as I can. Definitely looking for more people to jump on board, and whether it's just if you want to learn about the Atari Basic, or if you want to learn about Commodore Basic, you want to learn about Apple Basic, or Commodore Basic, I mean, you've come to the right place, even though we do kind of use graphics in this example. A lot of the simple basic examples will be used very similar into the other computers, because you can use 4Next also with Apple, Commodore, and Tandy, and any of the other 64-bit systems. You can also use it in C++. They have a different way of doing it, but it all follows the same logic. As you go further and further along in your computer experience and your computer knowledge, you'll see that it all came from the very, very beginning. So, hope you enjoyed this session as much as I enjoyed making it. Thank you.